Hi everyone, welcome back to the AI language. So in the last lecture, we designed this agent, right? We had a user input, which is a topic, and this goes to our root agent. This root agent is a sequential agent that creates questions about the topic. It answers those questions for which it uses a parallel research agent, and then so on. It basically, and in the end, produces a report in the form of an HTML and produces a final HTML output, which is a research report web page. Now, what if we want to deploy this to Google's cloud? All right, we want to deploy it to a cloud in a generic fashion that we can create a container and we can push it to some kind of a serverless environment. And for our purpose, we are going to use Google's Cloud Run as that serverless environment and deploy this agent over there. So that is the aim of this particular lecture. And let me go to the updated diagram for this agent architecture. And as you see over here, we basically have the same agent, but we have added three new components. 1, 2, and 3. So let me zoom in over here and explain these components to you as to how we will actually add it to Google's Cloud Run. So the first thing is that the ADK agent itself has to be run on a server. This server will then be serving the ADK agent, and you can hit this server using an API endpoint. So for this, we will create a server that will serve the ADK agent, and this is part number 1. So this is the first change that we need to do to our agent to be able to deploy it on any serverless environment. The second thing is we need to provide a fast API endpoint or some other kind of endpoint that can be hit from a web browser or from using a curl request or something else that the server can then respond on. So you can send a request on that API endpoint and the server can give you a response after running this entire agent below. All right, so that is the second part that we will add. And the third part is that we finally need to host it on some cloud. All right. So what we'll do is we'll create a Docker container, and this dotted line over here represents that container hosted on Google Cloud Run. All right. So we'll create that container, we'll create a Docker file, and we'll push it to Google's Cloud Run, which is a serverless environment from Google. And then this agent is going to run on that particular environment. You could very well take this Docker file and a container and actually, push it to other serverless environments from AWS or Azure or some other cloud that you want to put it on. And it should work very well over there as well. But for this particular example, I am going to use Google Cloud Run. There might be some differences between different serverless environments for which you might need to tweak it a bit, but the concept essentially remains the same. So let's take this step by step. Let's first see how we define this server. Then let's see how we do the fast API endpoint. And then finally, let's deploy this on Google's Cloud Run using a Dockerfile and understand how that Dockerfile is built. And finally, then at the end, we'll see a demo of how this works. Please note that in this lecture, I'll not be covering the working of the agent itself, which I have gone through in detail in our previous lecture. So in case you have missed that, you can look at the previous lecture to understand how this agent works. Just very briefly, essentially, it's a 6 agent sequential pipeline, and these are the 6 agents. So this is 1, 2, 3, 4, 5, and 6. And what this does is that it basically helps the user give a topic, which comes into the root agent over here. And then it generates some questions which will help the user understand those topics, answers the question using this parallel agent. So there are 5 questions and 5 agents run in parallel to answer all those questions. And then it finally generates a query for a web page creator that will actually create an HTML based research report. Right. And so that's a very brief explanation of how this agent works. But I would recommend that you go through the last lecture to understand this in more detail before you proceed with this lecture if you're interested, because that will help you understand how the agent works. In this particular lecture, we're just going to talk about the deployment aspect as to how you can get this agent online on Google's cloud. So let's move ahead with the first part. Alright, so this is the Visual Studio Code environment, and I have opened version 4 deployed to gcloud code. Alright, now this code folder has been added to the class repository, which is ADK_samples. So you can do a fresh git clone of the repository to get this repository again, and then you should see this folder over there. If you already have this repository cloned, you can update your local repository to get this new folder over here. Alright. Now, once you have cloned the repository, you will have a folder like this, ADK_samples with version 1, 2, 3, and 4. And you should directly open version 4 deployed to gcloud. And once you open this, you will see this open like this in VS Code with all these subfolders over here. Okay. Now, as the first step, we are supposed to talk about how we go ahead and build the server. So that's done inside the main.py file. And now I'm going to walk through that. All right, so this is the entry point for our deployment that we'll do on Google Cloud. So our multi-agent system will have this as the entry point where the user can actually hit this as a web app using either an API endpoint or using a web interface. And then this is going to generate a result after running the agent. Okay. And so these are the key components. So you have a FastAPI app which we have created using ADK's get fast API app. So we'll see this as we look at the code below. Then we have the configuration for the cloud run deployment. We have a session management setup. We have CORS configuration for web access, and we have the web interface enablement, which basically allows us to visit the URL and see a web UI that is provided by ADK itself. So a lot of the things are provided by ADK directly, and we are using them to build our to deploy our agent to Google Cloud and build the UI. All right. So there's some basic imports over here, and this is where we start with the code. So the first thing is that we want to get the absolute path to the directory where this main.py file is located, and this basically converts everything to that. So we get the path to the file, and then we take it as the absolute path, and then finally we get the directory containing the file over here, and we assign this to agent underscore directory. All right, so then is session management configuration. So what we might want to do is that we might want to store conversation sessions. All right, and over here we use a sample which is SQLite for simplicity. We provide this path for the SQLite database, which is relative to the containers working directory. And in production, where you might want a more robust database service, you might use other databases like PostgreSQL. Then we have cross-origin resource sharing configuration. So CORS is a very common thing that you need to actually define to allow access from certain originating URLs. All right. So what we do is we provide allowed origins as a list, and we provide localhost and localhost port 8080 and also star over here. So this is actually going to allow access from any origin, and whether you call your website the ailanguage.com or localhost or localhost.com or whatever, it's going to allow access. And what you would ideally do in a production environment is that you might limit the domains from which you want to allow access and only limit it to your company or your project's domain rather than allowing from all domains. Then we have the web interface configuration. So we'll say serve web interface equal to true. And what this flag will do is that it will allow browser based interaction with our agent. And this is just a ADK flag. So ADK is going to switch on that feature for us and provide a user friendly web UI for testing and interaction. All right. If you make it false, you'll only have the REST API endpoints, which is a headless mode. So you can only send, something like a curl request to get a response from the agent, but you cannot see the UI. All right. So it makes complete sense to actually set it equal to true for our testing. And then we can use the inbuilt web UI to interact with this agent. Now this is actually a development UI, so you might not want to use it in production. In production, you would probably build your own detailed application front end and integrate it using the REST APIs with this particular agent. Now we have the fast API application creation. So we use this function get fast API app, and this is provided by ADK. So it's provided by Google ADK CLI. And you see that we have imported it from Google ADK CLI fast underscore API. So that's actually great because it completes a lot of setup that is necessary for all the routes, the middlewares for serving ADK agents through the web interface and the REST API. Now, what we need to provide this particular function is the agents directory. So this is basically the agent directory that we defined above, but all our agents are located inside a subfolder, and that folder name is agents over here, right? So what we actually do then is that we use os.path.join, which is a Python module. The OS is a Python module over here, and this helps us combine the path for agent underscore directory and the subdirectory agents. And then ADK will automatically discover and load all the agents from this directory. Then we provide the session service URI that we saw above. So this is the database connection string for session persistence, and it allows maintaining the conversation context across multiple requests. Finally, we allow the origins using CORS over here. So essentially this educational code allows access from all origins. And finally, we have the web interface, which is switched on over here by setting this particular flag. Now, finally, we have the application startup and configuration. Now, what this does is that it handles the server startup and it provides a proper config for different environments. So if you're on a local development environment, it will use the default port 8080. If you're on Cloud Run, it uses the port environment variable that is provided by the platform. All right. So then we have the key configurations. So we specify host equal to 0.0.0.0. So this makes the server listen on all network interfaces, and this is required for containers like on Cloud Run. All right. Then we have the port. So it uses the Cloud Run's port environment variable and defaults to 8080. And then we have the Uvicorn server that handles the HTTP requests, and this forwards them to the FastAPI app that we have defined. All right. The first thing that we'll do is we'll try to get the environment variable port, and if we don't get it, we'll default to 8080 and assign it to port. And finally, we'll start the Uvicorn server. So what we'll do is we'll provide the FastAPI application, the instance that we get it above. We'll specify the host so that this listens on all network interfaces, and then we specify the port that we have gotten over here, either through the port environment variable or the default 8080 over here. So running this is going to basically start this server, listen on all network interfaces, and then forward the request to the FastAPI application over here, which is defined through this app. All right, so that is all that we do in the main.py file. And now let's go back to our architecture diagram. So this is our architecture diagram, and you can see that we have now started our Uvicorn server, and we are forwarding all the requests to the FastAPI endpoint. So both 1 and 2 are essentially handled by main.py. It provides you the FastAPI endpoint, and it serves the agent using the Uvicorn server. All right, so the next thing that we need to look at is this container. All right, for this, we need to define a Docker file. So let's go and have a look at this Docker file. Now this is our Docker file over here. And this is going to create a containerized version of our multi-agent system for Google's Cloud Run deployment. So the first thing is that we'll select a base image. So we'll use Python 3.13 Slim. And this is a lightweight Python runtime with minimal system packages. This is compatible with Google ADK requirements as well. Now we'll do the working directory setup. So we'll set the working directory inside the container to /app. And all the commands that we now run will be relative to this directory. All right, so they'll be executed relative to this directory, and this is where we'll put all our code, and all the dependencies will be installed in this particular directory. Now the first thing that we'll do is we'll copy the requirements.txt file to our working directory, and it just simply mentions the packages that we want to install. So we'll install Google ADK, we'll install Rich for the rich syntax part, we'll install Uvicorn for running our server, and we'll have the FastAPI app for which we need FastAPI package. All right, so let's go back to the Docker file now. Now over here, we are going to install the Python dependencies, and we'll specify the requirements.txt file using the -r flag. So this means that you need to install the requirements from this particular file. We'll run the command pip install, and this is an optimization flag over here so that we don't create or store a pip cache, which basically helps in reducing the image size. All right. Now for security, we're going to create a non-root user. We'll call that user my user over here. So the first thing is that we'll add the user. This user will not have a password, so they'll log in via key or token only. And we'll skip the interactive prompts for user information using this, and we provide my user as the username. Once that is done, we make this user own the app directory, because the app directory was created before the creation of this user. It would be owned by the root user. So we do this step so that this sets both the user and the group ownership to my user. All right. The -r does this recursively for all subdirectories and files inside that. And this just basically sets my user as the owner of the app directory. Now we need to deploy the application code. So we'll just do copy dot and dot. So what this means is that it copies all the files that are in our present project directory to the /app working directory. Then we'll switch to the non-root users. We'll say user my user. And this is now going to be applicable for all subsequent operations. And this ensures that the application runs with limited privileges. Even if there's a security vulnerability, the impact is minimized. All right. Finally, we have the environment configuration. We'll add the user's local bin directory to path, and this will ensure that any user installed packages are accessible. All right, so then we need to start up our container, and for that we use this particular command over here. So this essentially defines the command that runs when the container starts. And what this means is that sh tells the system to use the default shell interpreter. And this is a lightweight interpreter and available in all Linux containers. The -c flag over here is a shell flag that tells it to execute the following command string. All right. Now Uvicorn main app host and port over here. What does this mean? So Uvicorn is our server, and this will handle all the HTTP requests and connections that come in efficiently. Now this is the module colon object notation for importing the FastAPI application. So main is your Python file that contains our FastAPI app. And then app is the variable name of the FastAPI instance in main.py. So this is equivalent to saying from main import app. And this is the module object notification for importing the FastAPI application. The host mentioned over here basically binds this to all available network interfaces. And 0.0.0.0 over here means that the server is supposed to listen on all IP addresses, and this is required for Cloud Run. So the containers must accept traffic from any source. All right. If you don't provide this, this defaults to localhost, and Cloud Run cannot reach that particular interface. So you need to provide 0.0.0.0 over here. All right. Finally, we have the port flag over here. So this will use the port environment variable for defining the port to listen on. And Cloud Run automatically sets this, and it's usually 8080, but this will expand to the actual port number at runtime. So it's good to use this, and the application will listen on this specific port to receive traffic. So this is a summary of this particular command, and this will be run when the container starts, and this will launch our server ready to listen to any kind of requests. All right. All right. So we have covered our main.py file and our Docker file. The other thing that we need to do is we need to create an environment variables file over here. And this is different from what we have seen earlier. Now, since you're going to deploy this on Google's cloud, you do need a Google Cloud project with billing enabled. But don't worry about this, because I'm going to tell you how to create a Google Cloud project, and Google will give you $300. It might change here and there, but it'll give you some free credits in dollars to use for its services. And you can use that to cover this educational deployment and testing it out. So this is my Google Cloud project. You need to replace it with the Google project ID for your project that you create. Then we have the Google Cloud location. So I'm going to set it as US Central 1. And the important part over here is that you need to use a location where your model that you're using in Gemini is available. All right. So now if you've gone through the agent code, I'm going to open any one over here. So let's open the code writer and go to the agent.py file. And you see that we have a model specified over here. So I'm going to use Gemini 2.5 Flash Lite over here, right? Now to check for the Gemini model availability by region in Vertex AI, you can search for this online, and you'll get a link for deployments and endpoints Gen AI on Vertex AI. All right, so click on this link, and this is going to open this particular page over here. And if you go down to Google model endpoint locations, this is cloud.google.com/vertex-ai/generative-ai, docs, learn, and locations. All right. So you can see that you have all the model names over here, and you have all the regions over here, and then you have these locations over here. All right. So if you choose US Central 1, you see that most of these models are available. And if you use other regions, some models might not be available. All right. So we're going to use a region where most of the models are available for this particular code, and that's US Central 1 that we have chosen. All right. So that's the selection of the location over here. And then finally, you have Google Gen AI use Vertex AI flag, which is set to true. Now this flag tells the Google Agent Development Kit which backend to use for generative AI. Google's Gen AI SDK supports two modes of operation. So one is the Gemini Developer API, and this is sometimes also called the PaLM or the Generative Language Developer API. And the other is the Vertex AI Gemini API. And this flag switches between them. So in essence, if you have set this equal to true, what you're telling Google is to use Vertex AI as the backend, and the SDK instead calls Vertex AI's endpoints. within a Google Cloud project. So in this mode, it expects Google Cloud credentials like a service account and a project location rather than the API key that we have been using. So that's why you don't see an API key over here. To use this, you must have the Vertex AI API enabled in your project, and you must authenticate via a service account or user credentials. One more thing is that this does not use an API key, so there's no free usage as such. When you register for a Google account, you get some free credits, and if they are general credits, they will apply for the use of this Vertex AI generative AI as well, and you can use it to that extent for free. But please double check your usage. Like once you have used it, please check that the credits are getting used and you're not being charged for this, unless this might end up getting you a big bill for your usage over here. But for a simple run using our educational code, maybe let's say one run, that would be a very small number, a relatively small number, right? But if you use this extensively with this flag set equal to true, you might get a lot of charges on your account, and that's why we'll go through a cleanup step at the end. So I'm using this over here because this is what is recommended by Google for scalable and production oriented use cases. So that's why we are going to set this flag equal to true. An alternative could be that you set this flag equal to false and provide a Google API key over here, and you can still deploy to Cloud Run, and then it's going to use your Gemini API outside of Vertex AI. So that's another way to go about it. We are not going to use that over here. We are going to use this flag and set it equal to true over here. All right, so that completes our .env file. The next step is now to check this code out. So you can check it out from our GitHub repo, open this particular folder and be ready with the code and your environment variables over here. Now, once you are set up with your code cloned from the GitHub repo and you have set up your Google project and you have set up the G-Cloud command line interface, you can actually go ahead and start to deploy it. Now, since we're deploying it online, we don't need to actually work with our virtual environment. So what we just need to do is we can open a terminal over here. Inside the terminal, we first need to source all the environment variables. So we'll just write source.env and press enter. So now we have these environment variables available. Now we need to log into Google Cloud. So let's write gcloud login if you've not done this before. Once you do this, you can log in with a particular email ID and set your default project. I've already done that, so I'm not going to do it again. Now we'll simply deploy this from source code. So we're not going to build a Docker image. We're just going to deploy this directly from source. So what we can do for that is we can type our gcloud run deploy command. All right. So this tells gcloud to deploy on Google Cloud Run our service, and we name the service as website-builder-agent, and we then put a slash at the end to continue in the next line. The source is the current working directory. We specify the region as Google Cloud location from our environment variable over here. We set our Google Cloud project using the Google Cloud project environment variable. We will allow unauthenticated requests because we want to hit this service without the user being logged in. So for testing right now, we'll allow unauthenticated access. You might have authenticated access or you might set authentication checks at the backend in a production system. But for now, we are going to allow this unauthenticated access. Then we are going to set the environment variables for our service. So we'll set the Google Cloud project environment variables, and we are going to use the local environment variables, which are named the same over here. So this environment variable will be for the Google Cloud Run environment, and this is our local environment variable, and we use this list to set it up. We'll also specify a Google API key, but for now this will not contain any value. So this is going to be blank. And so we are going to use the Vertex AI flag over here to run. All right. In case you set the Vertex AI flag to false and then you specify this API key, you can actually use the API key and run this as well. And there's also a third mode where you can actually set this equal to true and provide an API key. In that case, this actually uses Vertex AI backend with something called express mode. So but I'm not going to get into all that. We're just going to use the Vertex AI flag equal to true, and we're not going to provide an API key. So before I run this, I should warn you that please do watch the cleanup section for this particular lecture as well, because we need to stop all the services that we have started so that we don't leave them open as they're unauthenticated, and we don't incur charges just for the services being deployed, even if they're not misused. All right. So let's press enter over here for now to deploy it. All right, so once you do this, you'll get a message that deploying from source requires an artifact registry Docker repository to store the built containers, all right? Because we've not built a local container, we're just deploying from source. So the Google will build it for us. And it just says that a repository named cloud run source deploy in region US Central 1 will be created. And do we want to continue? So I'm going to just say yes over here, as this helps us avoid one step to be run locally, and Google will do it for us automatically, all right? Alright, so now it's saying it's building using Dockerfile and deploying the resulting container to Cloud Run service. The service is called Website Builder Agent, and the project is specified over here and the region is specified over here. So you now need to wait for all these steps to complete. Now, once this completes, you'll get a message saying done, and you'll get a URL over here. So this is your service URL, and you need to copy this and open this in a browser, all right? So you can also command and click this and then open this in a browser. So this is how it is going to look in a browser. Let's just zoom in, and this is just like the ADK web interface that we've already seen. It's a development UI from Google to test your agent. So we can select an agent. It has all the agents that we had in our agents directory. I'm going to choose the root website builder over here. All right, so I have selected root website builder over here, and let me minimize this and then type in a topic over here. So let's say Google Agent Development Kit. So I've written Google Agent Development Kit, ADK is the topic, and let's press enter. All right, and now you can see that the same agent that we ran last time locally is running on Google's cloud, and it's actually produced the questions. It's researching on these questions over here. Let's go to the top to actually see how it did on that. So you see that it has created the 5 questions over here. So what are the core components and architectural principles in ADK and so on. So now you can actually have a look at this after running it yourself. And now it's actually working on the report, defining the footer, etc. And finally, it should give us the HTML code with the entire report. All right. So this is the entire HTML code that it has given, and it stopped working now. So let me copy this HTML code and head back to VS Code. Now, since I want to have a look at this locally, I'm just going to create a file called adk underscore report underscore, let's say .html. And then I'm going to paste the HTML code over here, and I'm going to right click and click on show in browser. All right. So this is what it has created for Google ADK, right? And you can see that it has talked about the architectural principles, the core components over here. And then we have the multi-agent system facilitation. We have tool integration and extensibility. So basically it has worked on ADK as a topic and produced a research report. And then you can actually have a look at this and see what all it has done. The content is not of importance over here, but just the idea that we were able to deploy this agent on Google's Cloud Run and produce this output by having the agent run on the cloud. All right, so once we have tested this out, it is important to do a cleanup exercise. So we can close the browser over here, and let's also close this. Now we're back in our terminal over here. Let me just actually expand this terminal. Now what we need to do is we need to clean this up. So the first thing that I'm going to do is I'm going to delete the service itself. So I'll write gcloud. So I'll write gcloud run services delete, then the name of the service, which is website builder agent. And then we have the region to which we deployed it, US Central 1, and then we press enter. So it'll say that this will be deleted. Are you sure you want to continue? So I'm just going to confirm it once and then say yes, because I know I just created it. And then this is going to delete this service. So now if you actually try to open this particular URL, this should not open up. All right, so now it says error page not found. The requested URL was not found on this server. All right, so we have successfully deleted that. The next thing is that if you remember, it also created a repository for storing the artifacts, right? So we can actually list those repositories by typing gcloud artifacts repositories list. So once you press enter, you'll see a list of repositories with the first column, which has the name of the repository. So for us, the name was cloud run source deploy. So I'm going to use that and now then run the delete command for artifacts repository. So I'll write gcloud. So I'm going to say gcloud artifacts repositories delete, and then I'm going to give the name, which is cloud run source deploy, and the location US Central 1, and press enter. And again, it will ask for a confirmation. So do confirm the name and then say yes or no. So I'm going to say yes over here. And then it's issued a delete request for this particular repository, and it's finally deleted it. So now this just allows us to, avoid any random costs for things that we're not using, that we just used for learning, and we don't need to actually keep these online. Okay. All right, so once you have done all this, you have successfully deployed your ADK agent to the web on Google's Cloud Run serverless environment, and you have accessed it through the inbuilt web interface using a browser. And we have run a particular query as well and checked the output, which actually ran pretty well on Google's Cloud Run. So thanks a lot for watching this, and I'm going to see you in the next lecture.